dielectric. Now here dielectrics, what are the dielectrics? Here dielectric, those substances which transmits electrical effect without conducting. Means substances which are transmitting the electrical effect without conducting, they are called the dielectric, and these are of two types. First, that is the polar molecule. Polar molecule means a molecule in which the center of the positive charge does not coincide with the center of the negative charge. Center of positive charge means, let us suppose this is the positive charge center, and this is negative. So this positive and negative, they get separated. So this is means positive charge, this is the negative charge, they have the some length, therefore it has the dipole moment. P is equal to Q into 2L. But the other type of molecules which are such that a molecules in which the center of positive charge and center of negative charge, they are coincided. For example, nitrogen and oxygen, means they have the net dipole moment is equal to 0. In this case, this is positive and this is negative. The positive and negative both are coinciding. They have no any separation. And no separation means they have no any length. Therefore, dipole moment is 0. But here, I want to make these non-polar molecules to make the non-polar molecules. Means I want to produce some dipole moment. How it will be? Effect of electric field on the non-polar molecule. Now here, now we consider here the situation. This is the capacitor plates, no charge is given, and between these two plates a dielectric slab is placed. This is the dielectric and this is non-polar. Here positive and negative, they are coinciding because electric field is 0. Now when we apply some electric field, charge is given, electric field is produced between the capacitor, then what will happen? This positive and negative charge, this is the positive and negative. When we are applying some electric field, due to this electric field, a force is acting on positive charge. And that force is equal to QE. This force is along the direction of the electric field. Similarly, force acting on this negative charge will be also the QE, but its direction will be opposite of this QE, opposite to the E. And thus, these two forces, they are acting in opposite directions. And thus, this positive and negative, which are coinciding previously, they get separated. Means here, same thing, positive charge gets pulled in the direction of the electric field, while the negative charge is opposite to the electric field, and thus separation between the charges continues till the forces acting on there due to this electric field are balanced by the internal forces, and thus in non-polar molecules becomes a polar molecules and is called induced electric dipole. And the dipole moment so produced, that is called induced dipole moment. So thus here what we have done, this is the non-polar molecule, it has no dipole moment. Now it changed into the induced dipole and thus electric field is produced. So here this is the induced. Now if suppose this positive and negative, they are quite nearer, then what will happen? Due to this positive charge, it will be represented as, this is dielectric slab, net negative charge left nearer to the positive plate of the capacitor, and net positive charge is left on the nearer to the negative plate of the capacitor, and thus electric field is produced. This is the induced electric field EP, and this EP direction is from minus to positive, whereas its a direction, so this is the positive to negative, this direction will be like this, its a direction is here, whereas due to which this produce, its a direction is here, this is the E0 direction, means this field is opposing the field, electric field due to which it is applied. The net electric field between the plates gets decreased, and due to which potential decreases. And when potential decreases, then the capacitance will increase. Now our topic is, we have to find the electrical capacitance of parallel plate capacitor filled with a dielectric slab. Now this is our question now. How we have to find out? Now look here. The same thing. This is the dielectric slab. Its thickness is small t. Distance between the plates is d. Field produced is EP. Potential difference between total potential difference is V. Now let a dielectric slab of thickness T of dielectric constant K is inserted between the plates of a capacitor, where area of each plate is A and distance is T, D, and this D is greater than T. Here T, that is this thickness. This is the dielectric slab. Now here, due to dielectric polarization, equal and opposite induced charges appear on the two faces of the dielectric slab, and these induced charges give rise to the induced electric field EP, and in the direction opposite to E0. And this reduced value of electric field in the dielectric, that is E0 minus EP, that is E. So thus now E exists in the region of the thickness T, and E0 field exists in the region of thickness D minus T. Here thus we have the two fields. One is here and second is here. So we know the potential E is equal to V by D. So what will be V? V is equal to E by E into D. So here we have the one potential difference produced by this dielectric, and one is produced due to the air. Here T is the thickness of the dielectric slab and D is the distance. It means that D minus T distance, that will be the air. So here total potential V due to air of thickness D minus T plus V due to dielectric of thickness T. So these are the two potentials. Potential is a scalar quantity. Now here V here means E into D, E0 D minus T plus dielectric ET, and we know E is equal to E0 by K. So what will be our expression? V is equal to E0 D minus T plus E0 by K into T. E0 taking common, what will be D minus T plus T by K. This is the potential, and in previous derivation we know E0 is equal to sigma by epsilon naught, and sigma, that is the charge by area, and this Q is CB. What is C? C is the capacitance of this parallel plate capacitor. It means that E0 is equal to CB into this. I am putting this value here. So what will be? V is equal to CB A epsilon naught D minus T plus T by K. We cut. So what will be the you get? C is equal to, so your formula will be C is equal to epsilon naught A D minus T plus T by K. So this is expression for the capacitance of the capacitor filled with a dielectric slab, and the C is greater than C0, where C increases on the introduction of the dielectric slab between the plates. Now here one thing, our formula is C is equal to epsilon 0 A by D minus T plus T by K. Right? Now case first. Suppose I am saying here is totally air. The air means T, no dielectric slab. So T is equal to 0. So your formula will be This will be the same. This is D. This T0, this 0, 0 by 0, 0 by K 0. So what will be C is equal to epsilon 0 by A, epsilon 0 A by D. This is what will be as acceleration. Case second. Suppose I am in full space. A distance between these two plates, a dielectric slab is produced. Means D is equal to T. So in our formula again, C is equal to epsilon naught A, D is replaced by T, T minus T plus T by K, T cut out, then C is equal to epsilon 0 A by T into K. Right? So this is C is equal to epsilon 0 by T is equal to D. Either we can read this is D. So C is equal to epsilon 0 A by D by K. This is medium. C medium. So when we will divide our again the previous formula, Cm by C naught is equal to K. So any type of the question comes out. Let us suppose the question is asked, a dielectric slab is placed between the plates of the capacitor of thickness D by 2. It means that T is equal to D by 2. You will put the value here. T is equal to D by 2. You can find out the value of capacitance of the capacitor. Now, our next topic is, if suppose I am connecting the two capacitors to each other, having certain charges, and now here, sharing of the charges by capacitance, that is the loss of energy. Let us suppose here we have the two conductors. One is first capacitor conductor C1, its potential is V1 and charge is Q1. For second conductor capacitance C2, charge Q2, and here this is, let us suppose this is the first conductor Q1 C1. This is second conductor Q2 C2. Then we know the here value of Q1 and C1. I can find out the value of V1. Similarly for Q2 C2 we can find out the value of V2. The here first, before sharing, I have not connected through the wire. Before sharing, what will be the total charge? Q1 plus Q2. We know Q is equal to CV. Q1 is equal to C1V1 and Q2 is equal to C2V2. So what will be here? Total charge is C1V1 plus C2V2. Now, let these capacitors be connected in parallel through the wire, metallic wire. Then what will happen? Charge will flow from a capacitor of having a higher potential to the capacitor at lower potential, and this flow continues till the potential of both capacitors become the same, equal. This potential is called common potential. So what will be the common potential here? Now let us suppose here, after sharing, what will be the new charge? Q1 dash is equal to C1V, Q2 dash C2V. Now total charge, what will be the Q1 dash plus Q2 dash? Put the value C1V plus C2V, so we taking common C1 plus C2V. So we know conservation of charge. Total charge before connecting is equal to total charge before connection. So here before C1V1 plus C2V2. After C1 plus C2V, so what will be the expression? V will be equal to the C1V1 plus C2V2 by C1 plus C2. This is the expression for common potential. Now, I want to find whether there is loss of the energy or not. Energy of first capacitor, we know energy is half CV square. So for first, half C1V1 square. For second, half C2V2 square. This is the before. So what will be the total energy before? Half C1V1 square plus half C2V2 square. After C1 new potential V square, second half C2 new potential V square. If suppose I am taking V square common, so what will be? C1 plus C2 V square. This is the after energy, right? So here energy loss, let us suppose delta U. I am considering the energy before shearing minus energy after shearing. Energy before shearing minus energy after shearing. So half C1 V1 square plus half C2 V2 square minus half C1 plus C2 V square. Now putting the value of V here. Now here I have substitute. This is the first capacitor. This is second. Minus half C1 plus C2 V value. C1 V1 plus C2 V2 by C1 plus C2 square. This is the value of V. This total is the value of V. This is the value of V. This one. Half C1 plus C2 V square. So here half. Now here. First term I have taken common. I have opened this bracket. A plus B whole square. Now look here, first square, second plus 2AB divided by C1 plus C2 whole square. 1 C1 plus C2, 1 plus C1 plus C2 cancel out, only 1 will be left. Again I have taken the LCM. So this C1 plus C2 multiplied by here, it will be the 4 terms. C1 multiplied by this, it will be C1 square V1 square. C1 multiplied by the C2, the C1 C2 V1 square. Now again same, C2 is multiplied by C1 C2 V2 square, and last C2 V2 square. Now here bracket positive minus minus minus. Now look here, C1 square V1 square and C1 square V1 square cancel out. Now here C2 square V2 square positive and C2 square V2 square minus cancel out. We have left half first term, second term, third term divided by this. Here C1 C2 common. So what will be the V1 square plus B2 square minus 2B1 B2 divided by this, and this is nothing, this is A minus V whole square. So our formula is delta U is equal to half C1 C2 upon C1 plus C2 B1 minus B2 square, and this is greater than 0, means if suppose V1 is greater than V2, then again this value will be positive. If V1 is less than V2, again this square will be the positive, delta U will be the positive, means total energy before shearing is always greater than energy after the shearing. And इसका मतलब ये हुआ, there is a some loss of energy when the two charge capacitors are connected together, and this loss of energy appears as heat energy. Now let us suppose we solve a numerical based on this. A numerical is asked, two capacitors of charges 6 microfarad and of capacitances. This is the capacitance. Two capacitors of capacitances 6 microfarad and 2 microfarad having charges 36 microcoulomb and 4 microcoulomb respect. They are connected through the wire. Find first part common potential, second total energy before connection, total energy after connection, energy loss in the connection. Now look here, first C1 is equal to this C2, Q1 Q2 given. We know Q is equal to CV, so V is equal to Q by C. So what will be the V1? Q1 by C1, 36 by 6, answer 6 volt. V2 V by 2, this is 2 volt. Now here our formula V is Q1 plus Q2 by C1 plus C2. I am putting the value, your answer will be 5 volt. Energy before sharing, half C1 V1 square plus half C2 V2 square. C1 we know, V1 everything we know. I have calculated this value, comes out 112 into 10 to the power minus 6 or 1.12 into 10 to the power minus 4. Third part, final energy, half C1 plus C2 V square. C1 plus C2 given, V is, what is V? Common potential 5 volt. 5 square 25. Solved out. This answer is 1.00 into 10 to the power minus 4. Now total energy loss delta U is equal to Ui minus Uf. Ui, this one value 1.12 10 to the power minus 4 minus Uf 1.00 into this. Your value will be 0.12 into 10 to the power minus 4 joule or minus 5 joule. By the shortcut way in our previous derivation, because our delta U is this one, half C1 C2 by C1 plus C2 into V1 minus V2 square. By applying this formula here, half C1 C2 upon C1 plus C2 into 6 minus 2. Simplify, your answer is 1.2 10 to the power minus 5. The same as calculated from this long method and from here the shortcut method. In this way, we can find out the common potential. We can find out the expression for the common potential, total energy before connection, total energy after connection, energy loss in connections. Thank you.